Alright, Kellenberg freshmen, here's your 10 minutes of rocks. Ready, get set, go. So rocks are divided up into three main groups. You got your igneous rocks. Those are going to be the intrusive and extrusive igneous rocks. We're going to talk about igneous rocks in a second. Then you got your sedimentary rocks. Those are going to be made at Earth's surface. They're formed from either sediments, clasts, or biological activities like little organisms. Metamorphic, any type of rock that has been subject to heat and pressure or fluid action. Now, we classify our different rocks based on how they form, so that's where we get our igneous that are going to be crystallizing, solidifying out of a magma or a lava, whereas our sedimentary rocks are going to be the result of weathering, erosion, deposition, and then we're going to need things like sedimentation, cementation, compaction, and lithification. Remember, metamorphic rocks, any rock can be metamorphosed, give it heat and pressure. We talked a lot about the rock cycle, and in a big picture, all rocks began as magma. Earth was a big bowl of molten rock, and then you started cooling and crystallizing, so you first got your igneous rocks. From there, it's one continuous cycle, and on any given day, a rock can become another type of rock. Now, we give the credit for that and the idea of the rock cycle to the father of geology, or James Hutton, who had the principle of uniformitarianism. Long form, the processes that are happening today are the same processes that happened in the past, or the present is the key to the past. That's the short version. When you guys look in here, you're going to notice that you have, again, magma will solidify or crystallize to become igneous, going around the circle, right? So you guys see which way we're going. Then from igneous rock, we can either melt, right, and become magma again. We can be subject to heat and pressure, which is going to make our metamorphic rock, or it can be weathered, eroded. You get some uplift in there. Remember that uplift is when rocks are going to move up to the surface, usually because you've weathered other rock material off, and you're going to get sediment. That sediment can then either be eroded, deposited, and bring us all the way around to sedimentary rocks. Sometimes that sediment might just get melted. It can become sedimentary rock and melt. You guys get the idea. Make sure you understand the rock cycle. Now, as far as igneous rocks go, we're going to want to work on our classifications. Again, all rocks we classify based on how they form or their origin, but then when we get down to the specific rock types, we have our igneous rocks. We say intrusive or extrusive, so did they form inside the earth slowly, large crystals, or extrusive, did it form very quickly on the surface from lava, small crystals. We also talk about it compositionally, so what are rocks made of? And that's where you're going to have things like felsic and mafic. So I put up this slide, you guys can go through it. Porphyry and vesicular are words that we use with texture. So as we said, coarse-grained or fine-grained. If we have a mixture, we say it's porphyritic, or it has porphyry. If it has little bubbles, as in pumice and scoria, we'd refer to it as vesicular, and that again kind of looks like a sponge. Now, I dropped in the rock identification charts from the New York State reference table as an idea for you guys to just look it over again. Do I understand? And look in here, you got your different types of igneous rocks. You have intrusive and extrusive, and then you guys can go across and see what happens with each one. Down here, you're going to see the color is going to be related to the composition. So go ahead, take a second, pause the video, try and understand it. It shouldn't be that difficult. Remember, we did this when we did our labs. It wouldn't be fair for me to leave igneous rocks without mentioning plutons. So we said that we have dikes, sills, laccoliths, batholiths, and volcanic neck. Just, again, look them over, be familiar with them. Could be a possible diagram. Speaking of diagrams, I kind of like this one. Not implying it's on the test, but I just think this is great because if you look in here, you have your batholith down here. You got the idea that a dike is going to cross-cut layers, that a sill is going to be horizontal in those layers, that your laccolith is going to actually push up on the other layers as it intrudes, and then in here would be your volcanic neck. Now again, your sedimentary rocks, the processes how they formed. You got deposition, you get compaction, cementation, all of that together we'd refer to as sedimentation or lithification. Be familiar with those terms, I think you'll be alright. So here, just a quick review about your 3 different groups for your sedimentary rocks. You can have your clastic, you can have your bio or your organic. Those can be used interchangeable, and then you can have your chemical. So therefore your clastic rocks are going to be formed from other rock material that's been weathered, eroded, and deposited. Compaction, cementation are going to be important there. So when we're cementing our grains together, we're talking about binding them, gluing them. It's simply smaller grains are filling in the cracks between, whether it's pieces of conglomerate, pebbles, then have sand and silt and clay filling in there. If we have a sandstone, then we have really fine clay and ions that are going to be filling all in. Alright, I'm just going to give you some light reading. Hit pause. These are your 5 main rocks that we talked about. Your conglomerate, your breccia, your shale, your sandstone, and your siltstone. Remember that shale is going to be made from clay, impermeable, good caprock or confining layer if we're talking about groundwater. Here you got sandstone. Sandstone is going to make a really good aquifer, and also you can see the stratification in there. You can see the layering. In terms of your chemical rocks, things like gypsum, some types of limestone, oftentimes you got things precipitating or falling out of solution and leaving rock behind. Organic, first thing I think of is coal. And there you go, you got stratification. If any of you were still confused, you got to be thinking layers. Back to rock identification charts. This is for sedimentary rock. You guys can find a cleaner version on the internet. Just type in sedimentary rock identification. Use this for the lab, but the key points here is you got your inorganic or your clastic sedimentary rocks and the types of rocks that you would get from that. Underneath that you have your chemical and your organic. Just take a second, look it over. Nothing crazy. And on to metamorphism and metamorphic rocks. Let's remember heat and pressure. That's where we're going to get the metamorphism from. That happens when you bury rocks deep inside the earth. We can have low-grade to high-grade metamorphism. If we low-grade metamorphose a granite, we get a gneiss. High-grade, we can actually go all the way up to a schist. Go too far, though, you're back to a magma, which means you're not making metamorphic rock. Next, you'll be making an igneous rock. The same thing happens when you take a shale to a slate, slate to a phyllite, phyllite all the way up to a schist. Again, go too far, you melt it, now you got an igneous rock. Also, let's talk about the scale of metamorphism. Contact metamorphism is just when you're having a rock that is in contact with a magma or some high temperature fluids that alter the rock due to temperature and pressure pushing in. Whereas regional metamorphism, that's going to be associated with mountain building, and that's most of what New York is. Each time there was a continental to continental collision, right, nothing's subducting, right, because there's no oceanic involved, so therefore, boom, you get these big mountain building events, and that's your regional metamorphism. When we do talk about metamorphic rocks, we are talking about foliated and non-foliated. Foliated meaning that there's layering or banding like a gneiss, whereas non-foliated means that it really has kind of like a coarse crystal look, and instantly I think of marble. Alright, so this was the classification that I put into your notes. I'll also show you the one from the New York State reference table. This one I thought was really clear. I like the coloring and showing you some of the parent material here and where you're headed. And again, in this video, the New York State reference table ones didn't piece in so well, but go look them up on the internet. You're going to see again that you got your foliated and your non-foliated, the different types of rocks. This here gives you an indication of some of the parent material and really compositionally what are we working with. So here again you're seeing foliation. You're seeing a gneiss. This came from a piece of granite that was put under heat and pressure, and therefore you got that metamorphism. And then by contrast, here's your non-foliated. So this was your quick review of rocks. I hope it was helpful. I would encourage you guys to go back and read your notes and maybe go take a practice test or two online just to make sure you understand what you're talking about. Good luck.